So, in the last few lectures what we have done, we have tried to find out the solution of partial differential equations using the Laplace transform, using Fourier transform. In Fourier transform, we have seen that whenever you are using either Fourier transform or Fourier cosine transform or Fourier sine transform, the given PD is converted into a first order ODE or a second order ODE, and the second order ODE or first order ODE solution we can find out very easily. So, that you are obtaining the u bar, and from u bar using the inversion function you are finding out u x t. In between you have to find out the values of the constants, because whenever you are solving the ODE, if it is the second order ODE, in that case there will be two arbitrary constants, whereas for first order there will be one constant. So, using some certain constants, certain conditions, we have to find out the values of those constants, and after that we have to find out the value of u x t. So, we have solved various kind of problems using the Fourier transform, Fourier cosine transform, Fourier sine transform, and we have tried to use the generic one, that is general function we have used, sometimes we have used in the conditions f x or g x, like that. So, that for any value of f x or g x you can find out the solution without resolving the problem again and again. So, let us take one or two more problems on this, and let us see how we can find the solution of the PD, and after that we will go to the finite Fourier transform. So, first let us see the example. We want to solve the following PD: del to u del t equals del to u del x square, x lies between 0 to 1, t greater than 0, with u 0 t equals 1, u 1 t equals 1 when t greater than 0, and it is given that u x 0 equals 1 plus sin pi x, where x lies between 0 to 1. So, if you carefully see the particular problem, here I have two independent variables x and t. X lies between 0 to 1 and t is greater than 0. Since x lies between 0 to 1, therefore, the question of using any transform, whether it is Laplace or Fourier cosine or sine, does not arise at all, because you know for the Laplace transform the independent variables should vary from 0 to infinity, as well as for Fourier sine and cosine transform, whereas for Fourier transform the independent variables should vary from minus infinity to infinity. Again, if you closely look this problem, here t is greater than 0, that means the range of t is from 0 to infinity, since t is greater than 0. But in this particular case, I cannot use neither Fourier cosine or Fourier sine transform, because the value of either u t is not known to me. U and u t should approach 0 as x approaches or t approaches infinity. That condition is required for this case. So, therefore, I cannot use in this case Fourier sine transform or Fourier cosine transform. Therefore, to solve this problem, I am compelled to solve it using the Laplace transform only. So, by this way, whenever a problem will be given to us, at first we have to determine that which would be the appropriate transform technique by which I can solve the problem. And again I am repeating, one particular problem may be solved by using more than one transform technique. We have shown it earlier, same problem we have solved by various techniques. So, we have to see which technique, which transform we should use, so that I can obtain the result quickly and easily and in better way. So, for this particular problem, as t is greater than 0, that is range of t is from 0 to infinity, and your values are given at x equals 0, it is given at t equals 0, the value of the function is provided. Therefore, I am compelled to use Laplace transform to solve this particular problem. To solve this problem, your function is del u del t equals del u del t, this is equals del to u del x square. and the conditions are given over here. I am just write down those things. So, here apply Laplace transform with respect to the variable t. Please note this one. We are applying Laplace transform with respect to the variable t. The reason we have told you, I cannot use any other transform technique over here. So, that whenever I am taking del to u s, this is del u del t, Laplace transform of del u del t, this is equals Laplace transform of del to u del x square. Laplace transform of del u del t is s u bar x s minus u x 0 from the formula. If you have noted, for the Laplace transform, the formula for Laplace transform of del u del t, all Laplace transform of del to u del t square are fixed. Whereas, for the case of Fourier transform, Fourier cosine or Fourier sine transform, it is not fixed, it depends on the variable, it depends on the particular values. Therefore, we are always evaluating the integral. And in this case, Laplace transform of del to u del x square, since you are applying Laplace transform of with respect to t. So, this del square del x square you can bring outside, that is, you can write it as d square dx square of Laplace transform of u, and Laplace transform of u is u bar. So, that this right hand side you can write down d 2 u bar dx square, where u bar is the Laplace transform of the function u x t. So, please note this one, that u bar is the Laplace transform of the function u x t. Now, according to the condition, it is given that your u x 0, it is given as 1 plus sin pi x, and x lies between 0 to 1. So, if I substitute this, then this equation I can write down d 2 u bar dx squared minus this will go on that side. So, s u bar x s, this is equals to minus u x 0. So, minus 1 plus sin pi x. So, whenever the second order PD is given there, using Laplace transform you are converting it into a second order ODE. Please note this one. The beauty of these techniques is that the PD is converted into ODE, or if you are trying to solve one ODE, in that case we are simply the ODE is transformed into some algebraic expression, which we have seen earlier whenever we have used Laplace transform to solve one second order ODE. I am directly writing the solution of this second order ODE. There will be two parts, CF and PI. CF part will be, if this is 0, so a e power root over s x plus b e power root over minus root over s into x, and in this case your pi will become 1 by s plus sin pi x by 1 plus pi square plus s. You will obtain this. You should check this thing. I am not going to discuss this one, because this again the first part is, this part is the CF part and the second part is the PI part. So, CF if you find out independently, PI if you find out independently, you will obtain this value, that u bar x s equals a e to the power root over s x plus b e to the power root over s into x, plus pi part is 1 by s plus sin pi x by pi square plus x. Now, what is your aim? Your aim is to find out now the values of these two constants a and b. And what is given to you? It is given to you that u 0 t, this is equals 1. One of the condition is given to you as u 0 t equals 1. Since u 0 t equals 1, from here you cannot do anything, because you got the result as u bar x x equals some function of x and s. So, u 0 t equals 1. if I take Laplace transform on both sides of the given equation, then I will obtain u bar 0 s. Laplace transform of u 0 t will be Laplace u bar 0 s equals 1, and that means Laplace transform of 1, that is equals to 1 by s. So, 1 you can use, that is u bar 0 s equals 1 by s, which we obtain from u 0 t equals 1. And we have been given one more condition, that is u 1 t, this is equals also 1. From here again, if you take Laplace transform on both sides of the given equation, in that case you will obtain u bar 1 s, this is equals Laplace transform of 1, which is 1 by s. Therefore, taking Laplace transform on both sides of the given equation, this you can write down u bar 1 s, this is equals to 1 by s. So, you obtain this. Now, in 1 if you substitute these values, u bar 0 s equals 1 by s. In that case, you will obtain u bar 0 s is 1 by s, and the right side it will be u bar 0 s, that is your x is 0. So, your a will be there, a plus b plus 1 by s will be there, sin pi by x term will be vanishing. This is equals 1 by s. So, you are getting this equation, which implies a plus b equals 0. Sorry, this will be a plus b, this is equals to 0. And similarly, if you substitute u bar 1 s equals 1 by s in the equation 1, what you will obtain is a e power root s plus b e power minus root s plus 1 by s, this is equals to, this is u bar 1 by s is 1 by s. So, that you can obtain from here basically a e power root s plus b e power minus root s, this is equals to 0. So, you have now two equations, one is this equation, another one is this equation. From these two equations, I have to find out the value of a and b. So, effectively if I write here, I have these two equations and I want to find out the solution of this. Now, if I take the determinant of this coefficient determinant, if I consider of these two equations, what I will obtain, this is 1 and this is e power root s e power minus root s. And this determinant value is e power minus root s minus e power root s, and this is not equals to 0. So, if I take the determinant of the coefficients, I am finding that this value of the determinant does not vanish, and once the value of the determinant does not vanish, means it has no solution, or in other sense we can say that your only trivial solution is possible. We can say that only trivial solution is possible. And what is the trivial solution for this case? Trivial solution will be a equals b equals 0. Trivial solution will be a equals b equals 0. So, please note that whenever I have to solve these two equations, you may try it in general, you will find that if I take the determinant of the coefficients, then determinant of the coefficients a 1 I am taking a plus b equals 0 as the first equation, and a e power root s plus b e power minus root s equals 0 as the second equation. So, by determinant is 1 e power root s e power minus root s, and I am finding that this is not equals 0. Since the determinant of the coefficient is non-zero, therefore, the non-trivial solution is not possible, only trivial solution is possible, and always trivial solution is a equals 0 and b equals 0. So, depending upon the nature of the problem, we have to find out the values of the constants a and b. In this case, Since only trivial solution is possible, we are getting the result as a equals 0 and b equals 0. So, by substituting this solution, you can obtain u bar x x. This is nothing but 1 by s plus sin pi x divided by pi square plus s. So, that your u x t is nothing but Laplace inverse of u bar x s. Your u x t you can write down Laplace inverse of u bar x s, and your Laplace inverse of u bar x s means Laplace inverse of 1 by s plus Laplace inverse of sin pi x by pi square plus s. Laplace inverse of 1 by s is nothing but 1, sin pi x will come out and you have only 1 by pi square plus s. So, sin pi x if it comes out into Laplace inverse of 1 by pi square plus s is e power minus pi square t. This you can check it of your own. Already this type of problem we have done earlier. So, that your solution becomes u x t equals 1 plus sin pi x into e power minus pi square t. So, let us see quickly, this was your original problem and you are finding the taking Laplace transform on both sides with respect to t, that is s u bar x s minus u x 0 left hand side will be, and right hand side if you take the Laplace transform it will become d square u bar by dx square. So, this u x 0 is nothing but 1 plus sin pi x. So, by substituting that value you are obtaining this differential equation. Solution of the differential equation is given by the equation 1, which has basically two parts, CF and PI part. First two terms a e to the power root x plus b e to the power minus root s into x is the CF part, and PI part is 1 by s plus sin pi x plus pi square plus s. So, once you obtain this, I have to find out the values of these constants a and b. For that I am using two conditions. One condition I know u 0 t equals 1. So, that u bar 0 s will be equals to 1 by s, and you have u 1 t equals 1. From here you can obtain u bar 1 s equals 1. So, the first equation, if I put it in equation 1, u bar 0 s equals 1 by s, you will obtain from 1 you will obtain a plus b plus 1 by s equals 1 by s, or a plus b equals 0. And if you put second condition, that is u bar 1 by s equals 1 by s, you will obtain this, and from where you will obtain a e to the power root s plus b e to the power minus root s equals 0. This is actually a homogeneous equation, because right side you have the 0. So, if you take the determinant of the coefficients, you are finding that the determinant of the coefficients are non-zero. Therefore, the trivial solution is the only possible solution, and trivial solution is a equals 0 and b equals 0. So, once you are substituting a equals 0, b equals 0, you will obtain u bar x s equals 1 by s plus sin pi by x by pi square plus s, and u x t is nothing but Laplace inverse of 1 by s plus Laplace inverse of sin pi x by pi square plus s. You know the values. Laplace inverse of 1 by s is 1 plus sin pi x into Laplace inverse of 1 by pi square plus s is e power minus pi square by pi square into t. Therefore, the solution of your problem is u x t equals 1 plus sin pi x into e power minus pi square t. So, like this way, depending upon the problem, I have to choose the appropriate transform, and then I can find out the solution of the problem. Let us take another problem. A string is traced and fixed between 2 points 0, 0 and L, 0. Please note this one, that it is traced and fixed between 2 points 0, 0 and L, 0. Motion is initiated by displacing the string in the form u equals lambda sin pi x by L, and released from rest at time t equals 0. I have to find the displacement of any point of the on the string at any point of time t. So, basically find the displacement, that is u x t, you have to find out at any point of the time. So, if you see here, your string is stretched between two fixed points 0 0 and L 0. Also, it has been told motion has initiated by displacing the string in the form u equals lambda sin pi x by L and released from rest at time t equals 0. So, effectively I have to formulate the problem first, then only I can think about the solution process. So, therefore, it may not be necessary that in the direct form the problem may be given. Sometimes a problem may be given like this, from where I have to formulate the problem, and after formulating the problem I have to find out the solution of that particular problem. So, to formulate the problem, the displacement which I can assume as u x t, this is the displacement of the string which is governed by the equation we have discussed this earlier, del 2 u del t square equals c square del 2 u del x square, where the fixed points it has been told from 0 0 to L 0. That means, your x lies between 0 to L and your t has to be greater than 0. So, your problem is now displacement u x t will be governed by this equation, del 2 u del t square equals, this will be c square into del 2 u del x square, where x will lie between 0 to L and t is greater than 0. And what would be the condition then? U 0 t, they were fixed at these 2 points 0 0 and L 0, these are the fixed points. So, u 0 t equals u L t, this is equals 0, because they were fixed at 0 0 and L 0. At x equals 0 the value is 0, and at x equals L also the value is 0. So, one condition is u 0 t equals u L t, this is equals to 0, and other one if you see the problem again, it is other thing we have told that motion is initiated by displacing the string in the form u equals lambda sin pi x by L and released from rest at t equals 0. So, therefore, what will happen again here, the other condition will be u x 0, this is equals to lambda sin pi x by L. At t equals 0, you are putting this thing, the motion is initiated and sin lambda pi x divided by L, and whenever you will take the derivative of this, since it is independent of this, therefore, this value is 0. So, since u x 0 equals lambda sin pi x by L and u t x 0, this is equals 0. Therefore, please note that for the given problem, I have to formulate the problem. So, first I am telling the displacement u x t is governed by this equation del 2 u del t square equals c square del 2 u del x square, where x varies from 0 to L and t greater than 0. Initial conditions are, one is it is fixed at 0 and another point is 0 0 and other fixed point is L 0. So, therefore, u 0 t at x equals 0 it is 0, at x equals L also it is 0, and a motion was initiated in the at the point u x 0 equals lambda sin pi x by L, and from here you can tell that u t x 0 equals 0 also. Now, if you see the problem, I cannot take any transform technique with respect to x, because x varies from 0 to L. Only t is greater than 0. Since t is greater than 0, I can solve it in some other ways also, but this problem also let us solve using Laplace transform, because u x 0 is given, u t x 0 is also provided over here. So, first I formulate the problem, now I try to find out the solution of this particular problem. What happens? You apply now Laplace transform with respect to the variable t. So that you will obtain, I am writing directly, s square u bar x s minus s u x 0 minus u t x 0. This is equal c square. This will be d 2 u bar d x square. I am not explaining again this term. Now, u x 0 is given as lambda sin pi x by L, u t x 0 is equals to 0. So, if you substitute these values, then you will obtain d 2 u bar d x square minus s square u bar by c square equals lambda s by c square into sin pi x by L into sin pi x by L. So, for this case, your solution of this problem will be u bar x x equals a e to the power s by c into x plus b into e power minus s by c into x. This is the CF part, and the pi part will be lambda x s sin pi x by L and divided by s square plus pi square c square by L square. Now, the Laplace transform on boundary conditions, from there you can write down u bar 0 s equals u bar L s, this is equals to 0. So, if I use the boundary conditions, one I will obtain a plus b, this is equals to 0, and the other one I will obtain a e power s by c into L plus b e power minus s by c into L, this is equals 0. And like other one, this is the homogeneous equation, like the previous problem, this will have the trivial solution only. So, that the trivial solution you will get a equals b equals 0. So, once you are getting a equals b equals 0, therefore, your u bar x s, this is equals to lambda s sin pi x by L divided by s square plus pi square c square by L square. So, that your u x t equals lambda into Laplace inverse of s by s square plus pi square c square by L square into sin pi x by L, I can keep outside because this is independent of s. And the Laplace inverse of this s by s square plus pi square c square by L, this is nothing but lambda cos of lambda c by L, pi c by L into t. This you can check it very easily, you can obtain this one into sin pi x by L. Therefore, the solution of this equation will be u x t equals lambda cos of pi c by L into t into sin pi x by L. Let us see it here. So, as I was telling you, you will obtain, the problem is given. So, displacement u x t of the string will be governed by this equation, del to u del t square equals c square into del to u del x square, where x lies between 0 to L and t greater than 0. u 0 t, the conditions, one condition, it is fixed at 2 points 0 0 and L 0. So, at x equals 0 and at x equals L, the function is 0. So, that u 0 t equals u L t equals 0, and also the motion is initiated by displacing the string in the form u equals lambda sin pi x by L. Therefore, at t equals 0, the value of the function is lambda sin pi x by L, and from here you can tell u t x 0 equals 0. So, the formulation of the problem suggests that I should better use the Laplace transform, and that is also with respect to t. because t's range is from 0 to infinity, whereas x lies between 0 to L. So, I cannot use x. Therefore, taking the Laplace transform on the given equation like earlier problems, I will obtain this, and I am getting the second order ODE as d square u bar dx square equals a square u bar c square equals minus lambda s by c square sin pi x by L. Its solution is of this form Cf plus Pi. The first two terms are for Cf and the last term is for Pi. Now, I have to find out the values of these two constants. The Laplace transform of the boundary condition is like this: u bar 0 s equals u bar L s equals 0. So, if I substitute this one equation, I will get a plus b equals 0. Other equation I will get this one, and these two are homogeneous equation, and like previous problem I can show that it has trivial solution. Therefore, a will be equals to 0 equals to b, both will be 0. So, that u bar x s is this function. So, u x t will be lambda into Laplace inverse of this into sin pi x by L. I can keep outside because sin pi x by L is independent of s, and Laplace inverse of s by s square plus s square form, which is nothing but the cos format. So, lambda cos of pi c by L into t into sin pi x by L. Therefore, your solution is u x t equals this thing. So, I hope that we have done various type of problems involving the partial differential equation, where sometimes it may happen that the problem directly is given to you, or sometimes in some form it is given, you have to formulate the problem. Then you try to find out which transform technique I should use or which is best suitable. One problem can be solved by more than one ways, and after that use the appropriate technique and follow the methods which we have done, and I hope you will be able to solve the problems of your own now.